All right. Thanks for that, Michael. So, my name is Molly Chapman, and I work for a company called FinnBiogas. So we design and build biogas plants, and it's a wholly Australian owned and operated company, and we work both nationally and internationally. So before I get into the presentation, I thought I'd just give you a bit of my background and role. I provide project management and technical consultancy support for projects, and I came into the Australian biogas industry back in 2011. I've been fortunate enough to have worked on some really great projects all around the country, including technical feasibility studies, but as well as the delivery of full plants. And importantly, I'm a big fan of Tasmania. I've taken my family down there a few times and we'll definitely be back again. So I'm really chuffed to be here to be talking to everyone. So I've been asked today to give you an overview into anaerobic digestion. So I'm sorry if it's a repeat for some people, but for people who don't know too much about it, it should be good. And then I'll give you my 2 cents worth on how I think it might fit into the Tasmanian context. So I'll start with some definitions. Anaerobic means in the absence of air. Digestion means the breakdown of biodegradable material. So anaerobic digestion is the breakdown of biodegradable material in the absence of air. So think contained vessel, as opposed to an open vessel, which is similar to like a composting process. So anaerobic digestion is a naturally occurring process, happens in marshes and things like this. And what's interesting about it is that it creates biogas. And biogas is high in methane content, so is useful for energy production. I'm not sure if you can see my mouse, but I'll run through a bit of an example to put this in context. So you have an organic waste feedstock, and this could be manures, food scraps. Think that you would put in your compost bin, but in the addition, you'd put dairy and meat as well. So you put it into an anaerobic digester, and this is a closed vessel. It could be a concrete tank, metal tank, could be a lagoon with a cover on it. And what we do is control the environment in such a way that we produce as much breakdown of biodegradable material and biogas as possible. So then you have this biogas product, and there's a few options of what to do with that. You can put it into a gas-fired generator and get electricity, and I've seen this at piggeries and wastewater treatment plants. You can put it into a boiler and use it for process heat. I've seen this a lot at abattoirs where they have a high heat demand. Or you can clean it up and have a almost natural gas quality product, and that could be used for vehicle fuel or put back into the national gas grid. And I've seen that a lot in Europe, not so much in Australia. Some of the other presenters might have some nuances on this process as well. So that's one product of AD, and then the other one is that you'll have this nutrient-rich substrate on the other side of it. So you've taken this high volatile solids organic matter, you've removed the volatile portion to biogas, which is a stinky portion essentially, and then you've left the nutrient in there. So that can be applied back to land. Now I know there's been a bit of conversation about the use of digestate and the value of it. I've seen it go 2 ways. I've seen it sold as a valuable product, and I've also seen it sort of given away because they don't want it to be a liability. For me though, taking nutrient in waste and then applying that back into the land is a positive thing. And the intricacies in structuring your project for economics and having the frameworks to support this is sort of a different conversation, but certainly it happens in Europe a lot. So what do anaerobic digestion plants do? They treat waste. So they take a stinky, high volatile solids organic waste and then turn it into this nutrient-rich product. And then they make energy, and that's sort of the crux of it. I thought I'd pop in some images of plants we've worked on to give you a bit of context, and I know you've seen a few already. This one here is in the Philippines, and it's processing chicken manure and chicken slaughterhouse waste. This is digesters here. There's this plant over here that's processing urban commercial food waste, and we worked on the latest digesters for this plant. So this one's taking waste from a number of locations. This is located with an industrial food processing facility. And then you have this one over in Costa Rica that was processing red meat abattoir waste. So that's a high-level overview into anaerobic digestion, and now I'll sort of give my opinion on how it might work for Tasmania, and I'm sure other people are going to have many other ideas, and the subsequent presentations might give you some ideas as well. So one is diversion of landfill and assisting in this process. Now, I know Tasmania is already looking at FOGO programs to collect municipal solid waste from the curbside. And if you haven't already, it might be possible to look at how to integrate anaerobic digestion into that process. I think a subsequent speaker might go into more detail about how that might work. Two is increased regional economic development. Now, that might sound ambitious, but in the Tasmanian context, where you have a number of food processing plants regionally located and farms, this could work really well because they might be producing a significant amount of organic feedstock and be able to benefit from AD or anaerobic digestion. The ways that an anaerobic digestion plant will contribute to a local economy are from a few different directions. First is from construction. Obviously, there's a number of locally sourced jobs for that. Then there's the operation and maintenance. You have a number of jobs created from that. But I think most importantly, it should increase the overall profitability of these facilities, which I think is important because it should have ripple effects in that local region. I'll just finish on talking about an example that we worked with or assisted in Tasmania. It was a local council just outside of Launceston, Meander Valley Council, where they were looking to introduce anaerobic digestion in an industrial context, treating waste from multiple facilities, where they would benefit from reduced energy costs from that AD plant. Now, I've run out a bit of time to talk about the circular economy, but hopefully some of the subsequent speakers will be able to talk about that. Yeah, so if you have any questions, please get in contact. We're always happy to have a chat, and I'll hand you over to Samantha.
Thank you, Molly.
Thanks very much, Molly. That's great. Okay, right, we'll go share screen. Here we go. How's that, Michael?
You're looking good.
Okay, great. Thank you. Okay, good morning. Thank you to the Tasmanian Government and Bioenergy Australia for hosting this event and inviting me to participate. Last weekend, I'd been booked to walk the 3 capes, so I was pretty excited, but that didn't happen, obviously. So looking forward to trying again in 2021. I'm the CEO of Energy 360, one of Australia's most experienced biogas handling companies. We work primarily in the red meat processing industry sector, engineering biogas delivery systems for covered wastewater treatment lagoons. Our technology captures the biogas which is trapped under the lagoon cover, and we pump it to the plant where it's used in a boiler to create steam or a generator to create power. Red meat processors need a lot of natural gas for their boilers, and biogas works really well in boilers. So it's a very straightforward economical solution for the use of biogas. However, we're expanding our capabilities with a technology partnership European partner to include biodigester systems. And this photo is a larger scale version of the project we plan to build at the terrific Utilitas Biohub in Bundaberg, Queensland. And you can see the large tank is where all the action happens, and the 2 smaller ones are for input and output storage. And this is a system designed and built in France. So Molly's done a great job describing what bioenergy is. I'm just going to add on, bioenergy plants in Europe are a contributor to the green credentials in that part of the world. And the aim is for bioenergy plants to provide some 10% of Europe's gas demands in the form of biomethane, which has been mentioned a little bit earlier by Kate. It's an upgraded biogas, which is a direct swap for natural gas by 2030. And this is part of the wider goal for renewable energy, both gas and power, to provide 32% of Europe's energy needs by 2030. So it's an excellent opportunity. So the circular economy. So just to reiterate it again, to describe the circular economy, I've borrowed from the Ellen MacArthur Foundation. She's taken her attention to detail from sailing around the world and honed it on providing insights and resources to, and I quote, supporting the learning and the systems thinking required to accelerate a transition to a circular economy. And the foundation states it's looking beyond the current take, make, waste, extractive industrial model, and a circular economy aims to redefine growth, focusing on a positive society-wide benefit. So if that's, we keep coming back to that, we enable the circular economy. And the world's largest companies in other sectors are also taking action on this sustainability and circular economy. BHP announced 2 months ago that they would prioritise actions on climate change over the payment of dividends to shareholders. Now, for me, that was a huge piece of news. L'Oreal will also be operating on 100% renewable energy by 2025, and BlackRock, the world's largest investors, pressing companies and stock exchanges to set a global standard for the disclosure and auditing of climate change risks. And Joe Biden also has provided a commitment to climate change. So should be some big things happening. So benefits for Tasmanian agriculture. So Tasmania Power is 80% hydro, which has a strong environmental headline. Bioenergy sits neatly beside this important clean and green reputation. In fact, it will provide an even stronger headline as it can generate power or biomethane, which is the upgraded biogas from an AD plant, and which can displace natural gas, as I mentioned previously, all from a renewable organic waste stream. The gross value of agriculture in Tasmania was 1.6 billion per abaras in 2018 and 19, and dairying and potatoes are the first and third largest sectors in Tasmania, producing also almost 600 million per annum, and they're ideally situated to use the organic waste from these two sectors as a part of the circular economy, providing that headline sustainability narrative. And then, so you can make a difference. There's a market urgency. We've got our current options: grid source power, heat and power. Take the waste to landfill, synthetic fertilizers, or change your light bulbs, or you can install a bioenergy plant. So there's multiple benefits that can be done by firms. So just a little bit more about Energy 360. We've been engineering biogas flares and delivery systems for over 15 years, and it's been predominantly in the red meat processing sector and landfill. We've also worked with wineries and food processors, and we're finishing a biogas delivery system for Harvey beef in WA right now. Luckily, they're not making any noise down at the factory, which will take biogas to a boiler to generate steam. We've worked with TEAS Australia to engineer, manufacture, commission a new biogas system for the Narracourt site, and this system draws biogas from 700 metres to the plant to generate power, replacing expensive grid source power. The photo on this page is our equipment at the TEAS Narracourt site. So we're taking the next step for Energy 360 to build tank-based systems in earlier slides, and we've partnered with Ukabit, a leading German bioenergy firm. You can see their name on the slide there, and they have 25 years experience and over 220 installations. So, so we're pretty excited about being part of the growing bioenergy industry in Australia. So thank you very much.
Thank you, Sam. Edward, over to you.
Thank you, Michael. In actual fact, we've got two speakers on the next session. We're lucky enough to have Frank Wennerberg, CEO of Combigas, who is set up very late in Denmark to talk to us today. So, Frank, are you there?
Yep, I'm online.
And I might just step back, and since you're looking very good for your hour of the night, but would you like to talk to us a little bit about your experience, which is pretty extensive in design and development of plants?
Yes. Yeah. Well, thank you. Thank you for being able here to participate together with all of you. Well, we joined the Danish Biogas Alliance a couple of years ago, and we are 5 companies from Denmark, and we are a broad range of companies. The first one is Gimmedan. They have a technology for depacking of food and for household waste, industrial products, etc. We from Combigas, we do the dimensioning and design of biogas plants, and we also do operation and support. Biogas Clean, they do removal of H2S, and Landia, they deliver all the pumps and mixers we have, and then Neras, where they also Neras has a local office where Edwards is the CEO in Melbourne. But altogether we have well, around 25-30 years of experience with biogas. And biogas, as we also say, it's Denmark is beer and butter, bacon and biogas. It's part of what we do. So a lot of experience with biogas during the last, well, approximately 30 years. Just a little bit about Denmark, and we are a small country in Scandinavia, but again, very similar with Tasmania. We have a lot of agriculture and food production, and we are actually forced, I wouldn't say forced by the regulation to produce biogas from our waste. So the circular economy is quite famous in Denmark, and we have again been doing it for the last 25-30 years. The biogas plants is owned by the farmers mainly, and then also some bigger cooperatives, as you probably know, Danish Crown, Arla Foods, and also some beer producing companies. There's a huge financial support from the government, so we can get up to 50% funds, or at least when we upgrade the biogas and put into our gas grid. Our gas grid network is widely expanded all over Denmark, so it's quite easy to get grid connection. And hereby, by putting the gas upgraded to natural gas quality, we can actually transport the gas not only all over Denmark, but actually all over Europe. And today, almost or a bit more than 20% of our biogas goes to the gas grid network. And it's just 6 years ago, it started. In Denmark, we have around 200 biogas plants. Well, the biggest part of it is from wastewater right now, but there's a huge development within farm and corporate biogas plants. Just to show where the biomass or the waste comes from, it's primarily from the livestock. The dark colors are where it's quite many farms. So we are, well, less than 6 million people in Denmark, but we have more than 30 million pigs. So the pigs are the biggest population in Denmark. We also have a big dairy production, and well, Arla is the biggest cooperative we have. It is quite important to have biogas if you have an organic farm, because that's actually the only way you can get a good fertilizer and you can use your waste products. So there's a huge focus in Denmark by using the digestate as fertilizer and optimizing this by applying it in the right way to the crops. So again, we have at least more than 20 years experience in how to do this part and to apply it in the correct way. Well, only 5% of the waste goes to landfill in Denmark, because we're recycling a lot of it, and part of it goes for incineration, but a huge part goes for anaerobic digestion. or just to give an example, in Denmark we are sorting all our waste in as private persons in minimum 6 different waste categories, and when you are in the industrial, you actually have 10 different waste categories you should sort your waste. I've taken a couple of examples of case stories. We have in Combigas, we have built more than 30 plants in Europe and also in Africa, and right now we are doing construction in China. Main part of the plants are farm-based biogas plants, and from an average capacity of 50 tons waste per day and up till I would say 700-800 tons per day. So we can design the plants so they fit to not only smaller farm-based plants but also to big industrial plants. The waste we are using can be manure, slurry, etc., but it can also be straw and silage if needed. We have together with Biomethane and or in the group the Biogas, the alliance, we have developed a concept where we take the pulp from the sorting unit from Biomethane and put it directly into the digesters. And we are planning to start the first plant in Victoria during next year and have commissioning in 2022. We have the similar plants in Denmark already, and here they've been operating for 3 years. We have just recently made a small, and I would say fairly cheap, farm-based plant for a simple feedstock, where we have a feedstock with less than 8% dry matter content. It can take 100 tons per day, and it is actually to use the power locally, and we have already had a couple of examples for that. It can be either for the farm, but also for the industry. One comment I would say about the process temperature, we are always using a thermophilic temperature. It's between 50 and 53 degrees, because then you have a much better digestion, and the capacity of the reactor is only the half compared to mesophilic temperature process. Yeah, just a comment about this micro digester, where we have a single stage. It's the one you just saw before, mainly farm-based, and then we have the bigger macro digester where it's a 2-stage digestion, and here we can take feedstock with up to 12% dry matter inside the reactor, meaning that we can actually apply up to 20-25% dry matter content. Yes, and for the Biogas Alliance, it is a collaboration, and Edward, he is present locally in Australia and Tasmania, so please be in contact, and thank you very much. I'll hand it over to Kunal.
Thank you. I'll just get on my screen. Oops. Michael, can you see the screen?
I can indeed.
Sorry, you can see the screen, right?
Yes, we can.
Okay, perfect. Thanks. Good morning, everybody. I am Kunal, Managing Director for Asia from Anerobic. This is morning from Singapore. And I'm going to talk about basically an interesting topic that you want to go towards decarbonization by using biomethane. Now, to produce biomethane, how do we ensure an interesting feedstock, which is usually untapped and which can unlock the organics value? So I represent Anerobic. Anerobic means anaerobic energy. So anything made out of organic waste. As a company, we convert different kinds of organic streams. So wastewater sludge, food waste, organics in solid waste, food processing waste and agricultural waste, and through a proprietary integrated solutions and technologies, we convert them into power, gas, recyclables, fertilizer, and clean water. Only disclaimer is that we only do this business. So we are only focused as a company on organic waste treatment. We are a Canadian company headquartered in Toronto, and over the last 30 plus years have built over 1,600 resource recovery and aerobic digestion plants globally in about 394 megawatt of installed power in about 4 continents. Singapore office covers Asia Pac. Some of the references, as I mentioned, about 1,600 digesters. And with that, I'll quickly jump into the topic. Renewable natural gas is a carbon negative fuel. And this is an established fact. We build a lot of plants globally. And this is a table I extracted from California Air Resources Board. And you can see here is that bio-CNG has one of the highest GHG impact potential in terms of a comparison between fossil fuels and renewable fuels. So any government, state, and utility wanting to decarbonize bio-CNG or biomethane or RNG, as we say, is a very nice way forward towards achieving the carbon neutrality goals. Now, having said that, there are different ways in school of thoughts on renewable natural gas, but let's say in Tasmanian, TASGas, who looks at in a substantial way to decarbonize the gas network. And as somebody mentioned in the morning, including Michael, you and Mac, that for an investor, he needs to have a reliable source of feedstock and basically a perennial source of feedstock. And yes, we believe this thing, what you see in front of the screen, municipal solid waste, can ensure continuous supply of biomethane. This is a feedstock which typically either lands in a landfill or to incinerators. But we believe on an average, and we have seen data in Australia, and I guess in Tasmania too, about 45 to 50% of the total waste, MSW, municipal solid waste, is organics. And this organics is generally untapped. And we have proprietary solutions to extract the organics from mixed solid waste. So there are, again, 2 schools of thoughts in Europe, in US, and various parts of the world, Japan, Korea. They go towards source segregation. What we have seen is that even though there is source segregation, when the food waste comes to our processing facilities, it is still contaminated, and the levels of contamination varies. But we believe that human behavior cannot be relied on in terms of a process. So this particular technology, which has been now installed in about 12 plants globally, is extracting organics from mixed solid waste. So as it is the waste which comes out of home, commercial facilities, we can extract organics. And those organics can then be further polished to remove further grit, bones, glasses, and plastics, and put it into an anaerobic digestion facility. So on the screen, you will see that there are 2 schools of thoughts here again. A is that unlocking the waste from residential waste, commercial waste, SSO. Now you can also add in the agri waste, food waste, and industrial organic waste. And then that is extracted. And then either you can send the organics to an existing wastewater treatment plant, and Hobart has a few interesting wastewater treatment plants, or send it to a merchant anaerobic digestion facility, which I will explain to you in the next slide. But then these are the 2 schools of thoughts wherein either you take it to a wastewater treatment plant for co-digestion. We have proprietary solutions here, and anaerobic digestion plants, which is a merchant plant. Again, a disclaimer, all the solutions have been proven and are working actually in operating plants for the comfort of the investors. So this is the current practice. Waste goes to a transfer station and goes to a landfill. Wastewater treatment plant, the sludge goes to a landfill. Typically, the wastewater treatment plant is a net energy importer. What we have figured out is that we can actually make the two talk and connect the dots between the waste sector and the wastewater sector. And this leads to better utilization of the existing infrastructure, so better return on investment on taxpayers' money, because the digesters or wastewater treatment plant infrastructure already exists. If you can extract the organics and send it to a wastewater treatment plant, there can be a synergy of co-digestion to produce RNG and as well a fertilizer. This is a global case study. This is, an old photograph. The plant has started. This is North America's largest food waste anaerobic digestion facility plus renewable natural gas facility. Now, apologies for the unit, but this facility makes about 1 million MMBTU per year of renewable natural gas, which is injected into the natural gas pipeline. It handles about 700 tons a day of organics extracted from MSW, and 300 tons a day of undigested dewatered biosolids from wastewater treatment plant, bringing to this facility. This facility is completely developed, financed, designed, EPC, and going to be operated by us. And just the beginning of this year, we had the interesting opportunity to have an Australian investor on board on this large project. So we are basically building a few more of these facilities in California because of the law of organics diversion from landfill, as well as incentives for renewable natural gas. Again, a quick, just to give you a background, that was MSW and organics. We also deal with Agri industrial organic waste. So this is again a very large facility we just commissioned in Holland. This will also make roughly about 990,000 MMBTU per year of RNG. And this handles pig manure, solid food waste, grass silage, and liquid waste streams from dairy, brewery, co-digested all, and produces renewable natural gas. I would like to summarize, because of the paucity of time, that for the investors, there needs to be reliability on the feedstock. And what are the feedstock? The municipal solid waste, which also attracts, fortunately, high gate fees. Second is, there is a possibility to leverage existing infrastructure between the solid waste and the wastewater of any council or town. And that is readily deployable. And it also helps local benefit. And for investors, this particular way of extracting organics, diverting organics from landfill, and then putting it into a digester and making a carbon negative fuel, I think this ticks many boxes of the HDC goals and has one of the highest ESG impact. With that, Michael, thank you, and happy to take any Q&A later.
Thank you, Kunal. Alexander?
Yeah, can you see my screen?
Not yet.
Not yet. Shit. Here we go.
Yep, you're good.
Perfect. Yeah, welcome everybody to today's Bioenergy Future webinar. So my name is Alexander Vogelsang, and I'm a process engineer at Aquatec Maxcon. To give you a bit of background information about myself, like I'm grown up in a region in Germany where almost every farmer has an anaerobic digestion plant. As we heard, it's quite popular in Germany. And then I decided to study about 5 years of process engineering with the focus on energy from biomass and waste. And I've got now more than 7 years of working experience in the biogas industry. And yeah, today I'm going to talk about, among other things, about the barriers and key factors of developing a biogas project. So I prepared the following summary. So I want to give you a brief overview of who we are, talk about a bit of the reference in Victoria and suitable substrates, and then the barriers and key factors, and ending up with the references in Tasmania. So first of all, like who we are, Aquatec Maxcon has been established in 1970 and is 100% Australian-owned company. So we're Queensland-based and got offices in Ipswich, and Melbourne, and Sydney. And we were now working for more than 50 years in the water and wastewater industry, and therefore have installed a lot of anaerobic digester as part of wastewater treatment plants. And so we're doing turnkey project. That means we've got engineering, fabrication, the electrical work, installation, and also operation all in-house. So I want to talk first about the reference plant in Melbourne, which is, I guess, quite well known within Australia. So this plant belongs to Yarra Valley Water. Aquatec Maxcon has designed and constructed this plant in 2016 together with the Germany technology partner Welltec Biopower. And Aquatec is operating this plant since 2017. So on this plant, about 100 tons per day of food waste gets processed, and we're producing about 1 megawatt of electricity. So 70% is exported to the grid and 30% is used on the sewage and recycled water treatment plant and the biogas plant itself. Based on these experience, yeah, I want to talk about on the next slide about the barriers. First of all, this is just a brief overview about suitable substrates we processing day to day. I think we've heard quite a lot about substrates today, so I want to keep it brief. In the end, it's commercial food waste, which we're accepting, and a lot of them are yeah, in liquid form. Coming to one of the main slides. So what are the main barriers developing a biogas project? Yeah, one thing what we've identified is that the commercial biogas plants are relatively new within Australia. I mean, that's one of the purposes why Bioenergy Australia is also organizing these workshops and trying to provide basic information and explanation to government, local regulations, and also to communities. So the location of the plant can be a barrier. Just thinking about any odor issues, or also the access for trucks, or another point would be the access to the gas grid. If we're talking
Jeffrey,
about...
I'm still in this bloody meeting and I can't get out of it. Can we scrub and we can maybe do it Wednesday? Sorry about this.
So anyone is just...
We'll do it later. I've got something on Wednesday.
Is anyone else hearing this?
Yeah, anyone else is talking right now. Sorry about that.
Okay, I'll talk to you a bit later. Thanks, right, bye.
Bye-bye. All right, where did I stop? So the location of the plant. So yeah, you need, so a barrier could be that you're not having the right access to, for example, the gas grid or the electrical grid. Two main points, I think, from my perspective, are the most important ones is the identification of suitable substrate. We heard a lot of, a lot of things are possible. A lot of technologies is out there to accept substrates, but I guess the main key is to identify suitable substrate for your own plant. And then the digestate utilization. Excuse me. We heard that Bioenergy Australia is working together with the government also to develop some framework and standards to actually make it easier to utilize the potential of digestate, for example, as application to land. That comes then to the next chart where where I summarize like the main points to or the key factors to develop the biogas project. First of all, we always recommend starting with a feasibility study, and as mentioned before from Meg from CFC and Michael from Pittwater Capital, it is very important to engage practical experts at an early stage. So that means, get someone involved who's got experience and long-term experience with different substrates to actually guide you through the process of deciding what kind of substrates you want to use and you can use, because there's nothing more expensive than a bad advice. So make sure you're choosing your substrates, because every substrate comes with the cost. For example, it starts with the pre-treatment, then the sizing of the digester, over to the operational cost, and then also it affects your digestate quality and the digestate use. The next point would be the AD technology provider. So we've heard that there are a lot of substrate out there which can be treated in different AD technologies. I'm going to show you two examples at the end, which are using different AD technologies. again, like I would recommend using someone with long-term experience, and also yeah, with the biological knowledge, because often what we can see in Europe is that plants are technical, okay, but yeah, often the biological sizing of digester can be an issue. And yeah, the last point is with the digestate application, make sure that you're looking at finding a good home for your digestate, and that it's bigger than actually the feedstocks which you're accepting, so that you're not ending up with the problem at the end rather than having a product. Yeah, the last two slides are about references in Tasmania. As I mentioned, so we've installed this plant in 1993 for Cadbury Chocolate Factory. This digester system treats high-strength organic waste streams from the factory. So it's not like the digestion process we've seen with the gas dome on top. So it's a upflow anaerobic sludge blanket digester. And then the last example I want to show you is a recent project we're doing at the moment. It's under construction. It's handling municipal and industrial waste in anaerobic digester, and it's for the Longford sewage treatment plant in Tasmania. And as I mentioned, so we're using abattoir waste in sewage sludge. Thank you very much. I hand over to Trip Allen.
Thank you, Alex.
Thanks, Alex. Let me just get my video going here. Good morning, Tasmania. My name is Trip Allen. I work for BTS Biogas. I'm based out of Singapore, covering the Asia Pacific region, including Australia, of course. I want to thank, firstly, the Tasmania Bioenergy Future Group and Bioenergy Australia for inviting me to participate. So just a very quick BTS overview, and I'll give more detail at the end. We're an Italian-based, US-owned biotechnology service company. BTS stands for Biotechnology Services. So we really focus on maximizing the energy output. One thing I like to note is, sitting in Singapore with COVID in such a large region, we are very partner-centric. So we will work with the required partners in Australia to bring about AD projects. So one thing I like to note is I have been to Tasmania, fantastic place. I know that the Tasmanian devil looks a lot different than the Tasmanian devil that I grew up with in my Warner Brother cartoons. And thank you very much for providing me breakfast this morning. That's an advertisement for Tamar Valley yogurt, which we get in Singapore, believe it or not. Let me share my screen. Okay, the big question, can everybody see my screen?
Well, you can.
Okay, let me present here. Find, there it is. Okay. So let me talk a little bit about biogas, a little bit of it, maybe general advice and what we've seen through 20 years of operation. First of all, it is an energy and waste solution. So this is a differentiator versus, say, solar and wind. And it does operate 24/7, which is another differentiator. I like to highlight that because that's what I believe is important. You always need to look at both the input and the output. I think this has been highlighted a few times. Your input is your feedstocks. Now, I think Kunal mentioned that feedstock is king. Your output is going to be your digestate and your energy, whether it's gas or electricity. So back to feedstock, we always say, what is your feedstock? What's the quantity of it? Is it contracted and secure? There are failures that have come about because all of the project has been put together, and in the end, they could not contract the feedstock. One thing I'd like to mention is there are a lot of variables, and I've seen a lot of them in the presentation so far, in implementing a anaerobic digestion project. So I think this has been touched on a little bit by some of the folks already, the financials. What we see is typically a plant runs for about 20 years. We look for and target a 7 to 8 year payback. One thing I'd like to mention that we've seen is probably 90%, maybe the scenarios, a grants or subsidies or environmental credits are needed to actually get an anaerobic digestion plant up and running and make it financially feasible. So working with the likes of ARENA, Matt Walden, and the ERF for ACCUs, which is the Australian Carbon Credit Units, we're looking to help decarbonize the gas networks throughout Australia. Just a few couple of general trends. The movement is towards biomethane, a clean, green natural gas. It used to be more behind the meter and feed-in tariff into the utility for electricity. We're also seeing what, so biomethane is in line with what TASGas is doing and what Kate said. So we're happy to see that TASGas is in line with that. Also, another trend we're seeing is what we call biohubs. This tends to be, especially in a place like Australia, where it's a large geographic setup, is a center of transportation and a center of feedstock, and could be multiple feedstocks, food waste, agricultural waste, et cetera. Hand in hand with possibly solar and wind to build what we call a biohub. I'm happy to send more information if required, if anybody's asking. So I'm going to talk today about a little bit about case study, because this is where the metal hits the pedal, called AB Agri in Milford, UK. So it's been up and running since 2016. Let me tell you a little bit about AB Agri. AB Agri is based in North Yorkshire. It is a food production company supplying the food supplying the food business overall. The key driver behind this project was environmental, and also a feed-in tariff. So part of this is behind the meter, but also going into the gas system. So there's a very attractive feed-in tariff. And again, if we look at that, the requirement for grants, subsidies, environmental credits, et cetera, were important in getting this up and running. So the feedstock you can see is listed here, a lot of liquid food waste, solid food waste, and green waste from the surroundings. This is their own feedstock, so not a problem with securing feedstock like I talked about earlier. The output is twofold. The output is a CHP and also biomethane. So that CHP covers the parasitic load of the anaerobic digestion plant. And of course, the biomethane feeds into the gas network and receives subsidies or pay on the tariff, feed-in tariff. Digestate is a liquid fertilizer that is spread upon the fields. Now, interesting enough, this required, because of the EPA, I don't know what they call it in the UK, but you call it in Australia, the EPA, which you need to look out for, is the need to pasteurize it. So that's how it was treated. I'm not going to go into too much detail here, but basically this is the plant diagram. On the right side, number one is the intake and the intake building, the feeding system, mixing of the feedstock. Then it goes into fermenters, and there are two fermenter tanks right here, and then into a post fermenter, and then into the final storage. From there's some other adjunct facilities, such as the gas treatment. And the CHP sits here, which is the combined heat and power unit, et cetera. Simple overview, mass flow depackaging into the food waste processing. F1 and F2 are the fermenters, and then the PF is a post fermenter. It's then pasteurized and put into a final storage. It goes out as a digestate and as a gas. So why did they choose BTS? There were 4 players involved, and BTS had a guarantee on an energy output. Also, there have been no problems whatsoever since 2006, the operation, 2016, the operation of this. Quick overview of BTS Biogas. I won't go into too much detail here, but we are, as I'd mentioned, an Italian-based but US-owned Bioenergy anaerobic digestion company. 20 years in the business, multiple plants throughout the world. I think the key thing is here, as I mentioned earlier, guaranteed solutions, and we maximize the energy and digestate output. So I mentioned earlier that we work very closely in partnership, and specifically in Australia, we're working with Helmont Energy based in Brisbane, Mark Yonkers and Roger Pattison, ex-EDL guys in the gas business. They're really bringing biomethane as a renewable energy source to Australia and decarbonizing the gas networks. So they have a background of power, biomethane, and understanding of local knowledge, which me sitting here and with COVID, it's difficult for me to get down there and get in front of all the customers and understand what's happening locally. In conclusion, on this particular project, AB Agri, keep in mind on all projects, again, it's an energy and waste solution running 24/7. There are a lot of variables that need to be taken in place. The feedstock is king, and you'll need to look into grants and subsidies to make this successful. So if you need to get in touch with me, my email address, my mobile number, please connect up with me on LinkedIn. And there's our good friend from Warner Brothers. I know the Tassie Devil does not look like this. I will hand this over to Maxime.
Good morning, Tasmania. Can you hear me loud and clear?
We can.
Perfect. Oop. Share my screen. Oop. Okay, so I'm Maxime De Keyser of Waterleau. I'm a service engineer based in Macau. Waterleau is a Belgian multinational company with its headquarters in Leuven. Leuven is a major city in Belgium with one of the biggest universities of the country. And that's also where the Waterleau story started, at the university. Waterleau at the moment has different brands like Crofta and is owned by the group Michiels. Our goal is to close the circle, and we have different technologies to do so. We have technologies in water and wastewater treatments, technologies in energy to produce some biogas. We have technologies to treat waste and also produce some biogas. And we have some air treatment technologies. We have more than 50 technologies, more than 30 licenses, and over 3,500 references across the entire globe. So some of our technologies that we use, the first one is Aquality. Aquality is a technology that we can use to treat ground and surface water to produce products water. We also have our Boomerang technology to treat treated wastewater and to upgrade it to processed water. When the water goes through the factory will produce wastewater. And there we have two ways to treat the wastewater. We have the anaerobic bioteam technology, which will produce biogas. And we have the aerobic bioteam technology, which will produce clean water. Our technology in the waste is also the bioteam wet anaerobic digestion. And with this technology, we can treat organic waste. After that, we can continue to dry and dewater the organic waste, organic solids, to create fertilizer that can be reused. We also have some gas treatment technologies, like the Biogas technology to remove H2S out of biogas. This to reduce the corrosion so that it can be used inside boilers to regain energy out of it. We also have the Bioton technology to remove volatile organic compounds out of the air so that we can produce clean air. Our business propositions, first of all, we do design and build. So we produce turnkey plants over the whole world. Every solution is custom made. So we adapt our solutions to the clients, to the specific case. Depending on the influent, on the inlet streams, and dependent on the required effluent streams. In Belgium, we have a big engineering team, so we can also do we can also propose only the engineering of the system. and so you can do your own building of the system. Next to that, we also provide O&M services, so the operation and maintenance of the plants. And at last, we also provide some services, digital services, but also process services to help you to upgrade and improve your processes of your current plant. Our case study in Tasmania is that we built a wastewater treatment plant in the Cascade Brewery. This brewery is one of the oldest of Australia. At the heart of the wastewater treatment plant that we have built is our anaerobic reactor, treating water and producing biogas. We are treating more or less 700 cubic meter a day, which will produce until 2,250 cubic meter of biogas a day. This biogas is treated by us and compressed and cooled down to remove the water and the H2S, and then will be reused in a boiler where it will produce some steam. If the boiler is out of service, we also provide a backup solution, a flare, to burn the biogas to avoid that all the methane will end up in the atmosphere. This is a part of the process and instrumentation diagram for the plant. So in the right upper corner, you can see the anaerobic reactor. You can see that we preheat our water. We do that with taking the heat out of the effluent towards the influent, so that we reduce the thermal energy consumption. This is the three-dimensional layout of our plant. So you can see the water is coming inside a fine screen. Then it flows to an equalization tank where it will be buffered. From there, it will flow to a pre-settler to remove the suspended solids, the biggest fraction of it. From then, it will go to our anaerobic reactor, where the biogas will be produced. From this anaerobic reactor, the water will go to a re-aeration tank to remove the biggest fraction of the smell. And from there, it will go to the sewage system. This is a picture from the roof of our anaerobic reactor, from where you have a nice view on the brewery. When we do our projects across the globe, we always work with local civil, mechanical, and electrical subcontractors. We provide our own site supervisor who will take the leads and guide these different subcontractors so that we have a smooth project. Waterloo has a unique selling proposition for different reasons. First of all, we have a lot of experience. We are already building anaerobic digesters since the 80s. So we have plenty of references, more than thousands in anaerobic digestion. We have projects all over the globe, from Oceania until over Africa to Europe to the Americas. We're innovating all the time. Our latest innovation is SmartLab, which is a platform on which you can monitor the processes of your plant, and which is more easy to improve the processes and your energy consumption of your plants. We are owned by Group Machiels, which is a strong and resilient group. So we have a strong financial group behind us with an entrepreneurial spirit. They also have an extended network for technical and financial aspects of the projects. We have been active in different types of industries. So we have been active in breweries, gelatin making industries, meat industries, dairy industries. So we have references in different sectors. We always make tailor-made solutions for our clients, starting from the influence, depending on the required effluent, of the required effluent goals for the clients. We use our own technology since we have plenty of licenses. The engineering is always done in Belgium. From there, based on the plans we make, the mounting will be done by local subcontractors and our site supervisor. At the end of the project, a specialized engineer will come by to do the commissioning and the startup of our plants. we are working together with some renowned partners like Suez and Engie. And yeah, we have an excellent after sales division for the follow-up of the different processes and different plants we have all over the world. Since we have different regional teams, we can guarantee a 24 hours assistance during the entire week. This is my slide for the Q&A, so I'll go rapidly over it. And yeah, if you have any questions, you're always free to contact myself, Maxime De Keyser, based in Macau, or my colleague Joris Moogs, based in Belgium. Thank you for your time and your attention. If you have some answers, please shoot. That was it. And I'm the last presenter.
Okay, Maxime, thank you very much. If you can clear the screen.
Yeah. How do I do that?
Good question. I think it says stop sharing.
Yeah.
It's technical. Huh? Here we go.
It's okay now?
Yeah, all good. Thank you. Okay. So we're going here. Okay. So how this is the holding screen. Can everybody hear me?
Yes, Michael.
Great.
Yes.
Okay. Thank you. Thank you, guys. But thank you very much to the presenters, and I'm trying to follow the Q&A as it comes through. But perhaps if I can just get us kick this off first of all. Perhaps can I ask you a first question there? I was interested in the concept of extracting organics from waste for you to be able to maintain a continuous supply of biomethane. What plans do you have that could give comfort to first-time adopters of this sort of solution, let's say in Tasmania?
Michael, great question. I think whenever we have dealt in building these plants and developing these plants, and as an investor, you would imagine that there are few stakeholders in these kind of projects. You have a waste department of a city or a council, then you have a wastewater treatment plant, which is a utility. Then there are investors, both equity and debt investors. So as a company, what we bring or what we try to de-risk the project and give comfort to the investors is by taking an integrated performance guarantee right from the waste reception design up to the biomethane production. The second is, of course, we operate almost 50 plants across the world. So operation and maintenance for long term. We do not hesitate to take equity stake on projects. So we invest into projects, our own projects, and we would be happy to invest together with a local investor, giving further comfort and putting skin in the game. And last but not the least is whatever technology we propose, we would show a running reference for that. So these are four key factors which would give comfort to equity, debt, investors, as well as the feedstock suppliers and the utility.
Great. Got it. Thank you. Thank you. And we have a question that's come through, which is on a similar vein, but perhaps I can direct this to Frank or Edward. So what does the household waste collection look like in Denmark, particularly with regards to household organics management?
Well, we have 4 collection bins inside the house, and we have 2 big collection bins outside the house. And the household waste, the food waste, are collected in small plastic bags. And then when it goes to the pre-treatment system, the plastic is sorted and everything is sorted. And then you get the pulp, which you can put into the biogas, and you get the plastic, etc., which you deliver for incineration. So, but it is the waste are collected by the local authorities in the regions.
And Frank, what about the commercial side of this? So restaurants and hotels, because generally there's a lot more waste food organics produced
but
there.
It's the same. They have the same kind of bins.
Yeah.
Where they put into just a bigger bins, and they are collected in the same way.
Okay.
Yeah.
Okay. Kunal, do you want to comment to the same question, not necessarily for Denmark, but your experiences in the same space?
Sure. So globally, there are basically, generally you can divide it into two schools of thought. So one is the source segregation, and that could be 3, 4, 5, 6 bins, or it can be all mixed together. Considering the population, globally 60 to 70% of the waste is completely all mixed, getting into the landfill, right? Including progressive nations. So what we have seen is that there is a slow movement towards source segregation. We are seeing that happening or going to happen in Victoria. However, in various parts of the world, it is very difficult, even in places where there has been source segregated mandated. Decades ago, I've lived in California, and I've seen that you still end up getting a lot of contamination. So we have a food waste plant in Toronto City, and a few other cities I would not like to name, but the point is that even though the plant was designed to handle only lesser contamination of food waste, what we end up getting into the food waste is iron rods, iron boxes, and stones and wood logs. So it is very difficult to have a pure source segregation. So in that case, what happens is that the proposition is towards having contaminated waste and then processing contaminated.
Got it. Thank you. Kate, if you're on the line, do you have any context on this with regards to Tasmania and how the waste organics are collected and separated?
I don't have any insights into it. I think that it's an area that needs greater focus, and I understand that there might be some announcements from the government in this space next year. I was at a presentation where the Premier announced that the waste energy strategy that was in draft will be released next year, and as part of that they will be looking at increasing waste disposal, so implementing a waste levy for the state, which I think is a great signal. It will hopefully make some of the anaerobic digestion projects more feasible if we can get more gate fee revenue for disposal.
Right. Okay, that'll be good. We look forward to that announcement. So, Molly, I see you've messaged me, Molly from Frontier. So, you have a comment to add on the commercial food waste collection?
Yeah, sorry, Michael. It's from FinnBiogas.
Sorry, wrong one.
I better give them.
Sorry.
Yeah, I just wanted to add on with the collection of commercial food waste. In the Australian context, I've seen waste collectors setting up depackaging plants. So they'll take Coles and Woolworths commercial food waste, and then they put it through a depackager, and then you have this clean stream of organic waste that can either be used in an existing AD plant or potentially they can set up a new plant, which I thought was interesting.
Yes, yeah, very much so.
Michael, if I just come in for a sec, I think one of the challenges we see there, though, is that a lot of that depackaging really isn't a solid decontamination. If we look to Europe, and I think, and Frank may speak a little bit about the Danish experience, where there is source separation, but we still see the levels, we still see contamination, as Kunal has talked about. But there have been some very interesting technologies and pulping technologies coming out of Denmark that are achieving decontamination well in excess of EU standards, particularly in terms of plastic contamination. Because one of the challenges with that depackaging that a lot of the waste collectors are practicing is there are still high levels, particularly of plastics, which are inhibitors to the gas process. Do you have any comments on that, Frank?
Yeah, I have, and we can take the company we're working together with, the Gimmedan. They have a 99.9 pureness of the pulp which are coming out, so there's no contamination in that pulp, and that is also why we're allowed to use it as fertilizer after the biogas process. And it's also another benefit that you can actually then collect all the plastic, etc., and then either reuse it or put it for incineration. So we don't need to be that when we sort the the organic waste in our houses or in the restaurants, they don't need to be very strict about it because it's actually sorted in the unit from Gimmedan.
Thank you. Look, it's a key point. It's clear. And but perhaps can I broaden, put a broader question out to all of the technology guys here? So waste to energy in particular here, incineration I'm referring to, it is quite topical at the moment in Australia, quite popular. Has anyone got a view in terms of co-location of bioenergy plants in the form of AD for taking the organic fraction from those? So a co-location of AD alongside thermal solutions. Have you got any experience in there, or do you have a view as to whether or not that's a logical way to go forward?
Maybe Michael, I go first if it's okay. Kunal,
sure, of course.
Right, yeah, it's very interesting actually. We are just commissioning our first plant in Taiwan, wherein this is co-located anaerobic digestion plant next to a waste energy plant. So the concept to everybody on the call is that, as we said, waste is almost 40 to 50% organic. Coming to this Southeast Asia or Africa or India, waste is almost 65 to 70% organics. Now imagine that organics contains water, low calorific value, and is organic in content, which goes to a mass burn incinerator. Now, simply law of thermodynamics would produce X amount of power, as well as it causes issues on the grade and leads to a lot of ash production, which has to go back to the landfill. And now this ash is hazardous. So we believe that there is a beautiful synergy which can exist between biogas and waste to energy. So let's say a waste processing facility, what we call the future waste processing facility should be, waste comes in, you extract the organics goes to an anaerobic digester, and you put it either power or biogas, which can be either injected back into the grid of the incinerator or make RNG. Now, only the reject fraction, which is the non-organic fraction, goes to the incinerator. So imagine 1,000 tons a day energy from waste burn. You take out organics, so you take out about 400, 450 tons a day. Your incinerator then goes down to half the size or even 60% of the size. So you have now a smaller incinerator, less capex. We all know incinerators cost a lot, less capex. At the same time, less ash production, which is hazardous ash, and so on and so forth. And one example which everybody should watch is here where we are sitting, Singapore, which is building one of the world's largest co-located food waste and incineration facility. We're talking billions of dollars. So that will be a beacon. But I think that's where we can look at least also in terms of infrastructure in Australia.
Thank you. Any of the other technology companies?
I can jump in for a sec, Michael. Just one of the
please
things.
do.
Yep, one of the things that Frank did talk about, and we, from our experience, and certainly in terms of projects that we are now developing here in Australia, is from the thermophilic process, we do have a lot of residual energy as well. So a lot of the opportunities we are seeing are not just around gas or electricity generation, but also the utilization in microgrids or embedded networks of that heat. Quite often we're looking at supplementing that with other forms of heat generation, so particularly things like solar boilers and potentially biomass boilers. So there's strong precedent in Europe for this co-location microgrid, leveraging of all of those byproducts or positive outcomes from this process. And it's one of the other major advantages then of the thermophilic process. So yeah, look, I think there's great opportunities here, particularly given our geographic nature, as mentioned before. This notion of biohubs, embedment, and local innovation centres where we do have this last mile of provision is a great opportunity in Australia.
Yeah, I agree. Yes, I agree. Anybody else like to comment? Go ahead.
I do have a client that they have a bit of a problem with their digestate. And they pay to get rid of it. So they are looking into drying and pelletizing and then combusting that digestate. So right. That's an interesting idea, but it's not happening just yet. And I haven't seen it happen in Australia, but it is something that clients are looking at, if that helps.
Yeah, thank you. Thank you.
We're fairly early on our commercialization journey. IQ Energy, we're producing a standardized modular gasifier oxidizer that basically arrives on a skid, so manufactured in a factory, arrives installed in a day or two, and then is live within in a week. And I guess we find that the co-location with someone who's going to use that thermal heat is the most efficient way to use the offtake. So rather than going to electricity, which has a massive 70% efficiency drop, we much prefer to be co-located with someone that needs that heat, like a boiler. It could be a manufacturer, it could be a pool or a hospital or someone else.
Yeah, thank you, Dean. That's interesting. If you want to share your details with me, Dean, or through Bioenergy Australia, well, I'd like to get back to you.
Okay,
that'd be interesting. Thank you. Does anybody else want to comment? Maxime, did you any experience in the same area of co-location?
We don't have that much experience with it because we have more industrial wastewater treatments and waste treatments, and we only do the digestion. We didn't do any thermal installation. So right, that's a lot.
Okay, thanks, Max. Are there any more questions? Questions here? I'll scan the chat, but I think I've picked up everything here. If somebody else is dying to jump on board, feel free to do so. Be careful, because I'll start singing ABBA songs if you're not careful. Okay. Okay, so there's a question in here. I'm not sure it's for this group. Is there technology available for processing 2 to 3 tons per day? I guess they mean organic waste. Any of the speakers wish to comment on that in terms of size of project? Very small. Some of the European technology, I guess, would be in that space.
Mark, sorry, Michael, I've actually answered that one and suggested that they contact Gecko in Ballarat. They do a container solution.
Good call.
Yeah, it's good. They've got really great. They come from the mining industry, and it's really strong technology, from what I can tell.
Very good. Okay, thank you. You should be sitting here. I can't multitask as well as you. Okay, look, I think we're 4 minutes away from being diverted back. If there's nothing else, we can grab a coffee before we get diverted back to the main event. Can I just take this opportunity to thank all the presenters for your valued contribution and for all of the questions.
Thank you, Michael.
No problem at all.
That's not here.
Thanks, Michael.
Thank you.
My pleasure.
Thank you, Michael. Thanks.